Hi, 7th graders. We are on lesson 2-1, expressing rational numbers as decimals and decimals as fractions. So a rational number, as you may recall, is a number that can be written as a fraction. So that includes everything inside this box. So whole numbers, integers, fractions. I wrote positive, negative, integers, zero, fractions, decimals, whole numbers, repeating decimals. So you can write any whole number or any integer as a fraction because you can always just put 1 under it and it's a fraction. Zero, decimals. So all of these are examples of rational numbers. Okay, a terminating decimal. And just a reminder that you should have your vocab sheet out. You can already write down rational number that we just talked about, and then here's a couple more vocab words from your sheet. So write these in as I'm talking about them. A terminating decimal is a decimal that ends. So 0.64, 1.23567, 9.3, you can see that they have an ending. Repeating decimal has a pattern of digits that repeats forever. So if you look here, 0.33333333, that's a repeating decimal. It goes on forever and ever and ever. It doesn't have an ending. One way that we can write it is with 3 dots after the end. So this tells me that this is a repeating decimal. It goes on forever. Or we can write it as 0.3, and the repeating part, which is 3, has a bar on top of it. And that is called bar notation, which is also on your vocab sheet. Okay, so this is an example of bar notation. Here's another example of a repeating decimal. Notice that 3, 4 are the numbers that repeat forever and ever, so the bar is only over 3, 4. Okay, one thing, if you were to enter in a repeating decimal on your calculator, like 1/11th, if you have your calculator nearby and you want to put it in, you would see that it would go, because 1/11th is 0.09 repeating, which really is 0.090909 forever and ever. But your calculator is going to round the last number up, so it looks like it looks like that it stops and it has a 1, but you know that it's repeating if it has all these numbers the same, and then there's the number that it's rounded up, because for instance this would be a 0 and a 9, so it just rounded it up to a 1. So I just want you to know that it looks a little bit different when you're on your calculator. So how do we convert fractions to decimals? Well, one way we can look at fractions and we can see if we can convert it to a 10 or 100 or 1,000 for our denominator. And we can see that, well, yeah, if we multiply both the numerator and the denominator by 2, because remember, whatever we do to the top or the bottom, we have to do to the other one. So if we multiply both, we can convert it to 4/10. Okay, so 2/5 is equivalent to 4/10, and we know that 4/10 is equal to 0.4, because the first value after the decimal point is tenths, so we would say this is 4/10. We would read that as 4/10. Okay? If we looked at this one, 34/50ths, and we wanted to convert it to 100ths, okay, so do that really quick. Convert it to 100ths. So we know that if we multiply both sides again by 2, we would have 68/100ths. And we would write it as 0.68, which is also the same as saying 68/100ths, because here's our tenths place, here's our hundredths place, so 68/100ths. Okay? Why is it the same slide? Okay, so now we look at a new fraction and we see 5/8. Well, we can't write 5/8. We can't convert it to tenths or 100ths. We know off the top of our head that it doesn't go into that. So now, but we still want to be able to convert it to a decimal without a calculator. So what I'm going to do is I'm going to take, that is not a good 5. Okay, I'm going to take 5 and I'm going to divide by 8. Oh, I was going to try to pause this for a second, but I can't figure out how. Okay, so we know, so notice that I'm doing 5 inside my box because that's the number that we're dividing by. So I'm not putting 8 inside, I'm putting 5 divided by 8. Well, we know that 8 cannot go into 5. So I'm going to add a decimal and I'm going to add a 0 because we know that we can add as many zeros after a decimal and it's still the same. Okay, so how many 8s in 50? Well, we know that there's 6 8s in 50, so 6 times 8 is 48. Okay, 50 minus, and I'm going to take my decimal and I'm going to actually put it right up above on top. So 50 minus 48 is 2. Well, 8 can't go into 2, so we're going to add a 0, and then I'm going to pull my 0 down. So how many 8s in 20? Well, 2. And then I do 2 times 8 is 16. How many 8s in 4? Because 20 minus 16 is 4. Well, 0, so then we have to add another 0. Pull my 0 down, and there's 5 8s in 40. So 5 times 8 is 40. And then we know that that's 0, so then that's our answer. So 5/8 we would write as, and we can add a 0 in front of here, 0.625. So I want you to do that same exact method with 7/8. And then, so pause it, do it, and check back. And your answer, I'm not going to do all of the work, but your answer should be 0.875. Okay, if not, go back and try it again and do these same exact steps. Instead of a 5, you have a 7 right in here. Okay, so if you got that wrong, go back and double check. Okay, so now we have a fraction, but it's going to turn into a repeating decimal. So how would we write it as a repeating decimal? Well, first of all, I have my 3 that I'm going to circle. And remember that I have to go back to that. And for now, I'm going to do the same exact thing. I'm going to go 1 divided by 11. Okay, we know that 11 can't be multiplied by an even or a whole number to get an even 100. We know we can get to 99, which is really close, but we're going to do it this way. So we have 1 divided by 11. 1 does not go into, or 11 does not go into 1, so I add my decimal. Well, 11 does not go into 10 even, so that's 0. 0 times 11 obviously is 0. So I'm actually just going to add another 0 and see, well, how many times does 11 go into 100? Which is 9. 9 times 11 is 99. 100 minus 99 is 1. And I add a 0, pull it down. Well, I know 11 can't go into 10. So I'm going to add another 0, pull it down. 11 goes into 100, so I'm going to, first of all, extend my line. And I have 0, 9. 9 times 11 is 99. So here we're seeing that we have a pattern, and this is going to go on forever and ever and ever. Okay, so what I do is I tell myself, well, it looks like it's going to be going 0.09090909. So now I know that 1/11th is 0.09 repeating. But we still have this 3, so that tells us that there's 3 wholes and 1/11th. So the way that I would write this would be 3.09 repeating. Okay? I want you to try this one, 7/12. Okay? And without showing you all of the work, 7/12, you should have gotten 0.583, and it should be 0.58333333. So then your repeating number is 3. Okay? And my computer is about to die, as you just saw that. Okay, write a decimal as a fraction. Well, how do we write 0.32 as a fraction? Well, we know that 0.32 is we would say 32 hundredths. So that's how we would write it as a fraction. But we know that it can be simplified more. I know in my head that, well, 32 and 100 can both be divided by 4. 32 divided by 4 is 8. 100 divided by 4 is 25. So our answer in simplest form, 0.32, is the same as 8/25. Okay, try 0.96. And you should have gotten 96 100ths. And if you divide them both by 2, you would get, what would you get? 48 50ths. And then I can divide them both by 2 again. And you should get 24 25ths. So 0.96 or 96 hundredths is the same as 24 25ths. We're going to skip this slide. And so now this is the end of your video for 2-1, so make sure you go back or go on NICU and do your 2-1 quiz. Also go back and make sure you have your vocab filled in for rational number, terminating decimal, repeating decimal, and bar notation.